Morning. Uh, my name is Dr. Imran. I am Associate Professor in Department of Food Science, Government University, Faisalabad. Currently, I am doing a postdoc in University of Melbourne, Australia. Uh, Thanks for providing me opportunity for this online talk. We are very informative and very state of the art and the need of the art conference, which is titled as the International Brain and Biomedicine Conference. I have honored to be served as a member of the organizing committee, and I'm very thankful to Professor Dr. Ghulam Hussain Saib who provide this great opportunity for all of the participants and provide such a huge and big event in front of all us. The topic of my presentation is basically the antioxidant efficient extraction and antioxidant profiling of polyphenols from different waste for sustainable resources. This is the outline that I am going to be talk like background, aim and objectives, such plan, such methods and rationale, and the end of the finding. The base of my this topic is that agro-industrial waste is producing in a huge amount, causing a problem. Why? Because they are producing a huge volume. They have an impact on the climate, and they are really perishable. So all of these things demands that some rational solutions, not only for their disposal, but also to get some beneficial things from them, because they have a lot of the things that can be utilized in a different industries, not only the industries like the board industry and other industries, but also for the pharmaceutical, nutraceutical, even the food industry. Meanwhile, our changing climate causes severe impact, and food insecurity is the basic problem, is a fundamental problem of the developing economies, and demanding some solutions which is not only efficient but also the environmental friendly. In this scenario, waste reduction, reutilization, recycling has been should be accomplished, should be adopted, because both of these can ensure the food security in the country. So, agriculture waste generation pathway, as well as its concerns, it comes from a farm to the fork. From crop residues, you can see that rice straw is a great source for the oregano, wheat straw, great source are the phenolic acids, corn strawers, barley straw, all have some beneficial component. The second, plant metabolites, polyphenols, phytochemicals, having a huge potential to be incorporated into different health conscious products. Livestock waste like the cattle manure due for the energy production, poultry waste go with the energy production, biofuel production, and other things that. Like agro-industrial waste, like sugarcane, because in Pakistan really is a great opportunity for all of us to use this, because it currently is using in a production of the chipboard and other cardboard industry, but it can be utilized for the production of some health based beverages, rice bran husk, de-oiled seed cakes, fruit peels and pulps, all of having a different agro-industrial waste, and they have a different potential to be utilized in a meaningful way, like aquaculture having the same phenomena, having the same potential. So when we see the current and predicted graph of the agriculture waste generation, you can see that it's not only the current problem in many countries, but also projected to be predicted to be enhanced in almost twice in the coming years. So it is really a problem, and we need to be tackle it. We need to be understand the problem, and we come up with some solutions to not only tackle this problem in a meaningful way, but also the extracting or the attracting the some beneficial component from it by reusing it, recycling it, or the waste management. Agro-industrial waste utilization is basically of two types, is the agriculture residues as well as the industrial residues. And agriculture residues further subdivided into the two classes. First one is the field residues, another one is the process residues. In field residues, stem stock, leaves, and the process residue is something like that. Where the industrial residues, the byproduct of the main main component used in that industry. Like in the potato industry, potato peel is the industrial residues, orange peel, cassava peel, everywhere. Whenever the main product is utilized, the remaining of that is considered as the industrial residues, and these residues is, believe me, having a great potential to be utilized into the functional pharmaceutical and nutraceutical products. If we consider the food waste situation in Pakistan, yes, Pakistan is unfortunately we are having a 60% of the people who are food insecure, 43% remain the food insecure, the moderate, and 80% the severe food insecure person. However, look at the data. 40% of the food produced in Pakistan, around 36 million, which is the accurate figure, is wasted in each year. So could you imagine if we save this 40%, we can reduce almost 40% of our food waste, food insecurity situation in Pakistan. So food waste or loss is food waste or loss along the entire supply chain. What does mean food waste? The food waste that we can like in the stem straw and other like the field residue, the residue, the loss is mean that that we are left over the plates and other things. Low, so production, handling and storage, processing and packaging, distribution and the consumption, all of these channels, our food has been lost or wasted, and if we tackle these things, we can manage to reduce the food insecurity at a certain level. So the circular economy is very important for every country and especially for the developing economies. Circular economy is a concept where the waste used as a resource. So agro-food industries, residues, and liquid cultures, microfungi, added value bioactive component, and they are used in industry like the functional food, pharmaceutical, nutraceutical, chemicals, and enzymes. So they can be easily managed to the enhance to the circular, manage the perspective of the circular economy. Waste valorization pathway, yes, if we valorize the industry or the field or industrial residues, we can obtain polyphenols and all of these substances, and there is a huge perspective that the different industries where we can be incorporated these waste into the different industries. So hypothesis of our research is the extraction of the nutraceuticals from the agro-industrial base. Currently, in the University of Melbourne, I'm using a different kind of a waste material, and this paper is particularly from the peels. However, I've also utilized the rice bran from cereals, from some products from cereals, some products from the legumes, some products from the oil industries, and some products from the fruits and vegetable industries. So this is the adopted methodology for this type of research. First, we're using the different raw materials, estimation of their phenolic contents, estimation of the antioxidant capacity, phenolic contents from the 96, the state-of-the-art assays we developed in the University of Melbourne by using the 96-well plate, and the antioxidant estimation of antioxidant capacity by using the 7 state-of-the-art assays, including the FRAB, DPPHA, BTS, ORECA, OH, and like that. Then characterization of phenolics has been done by using the liquid chromatography, SIQ of mass and mass spectrophotometer, and tentative characterization of compound by doing the adjuvant library as well as the personal group library, and then quantification of some special compounds from the HPLC PDA componation. So this is the tentative, or this is the adopted methodology that we are using. So sorry for that, I'm not attaching the tables here because in a University of Melbourne, we are not allowed to be present the research before it's published. So I just provided the findings of my research. The outcome shows that there's a different, I'm using 2 modules, extraction modules, ultrasound as well as the conventional one, and in this category, ultrasound imparted the better yield as compared to conventional one, and as far as our observation and confirmation from our observation and confirm from the literature that ultrasonic extraction provides better extraction yield due to its cavitation process. This cavitation process is essential and effective to disrupt the bond between the phenolics and liberate them more efficiently as compared to conventional one. All the studies material exhibited the promising phenolic estimation and antioxidant activity. We also do the correlation analysis, and correlation analysis revealed a strong positive correlation between the TPC and various antioxidant activities in study material, indicative of their influence its diverse phenolic compounds. However, FRAP and TPC show particularly the strong correlation, show that ferric reducing antioxidant power chelating ability is more prevalent in the pills as compared to other mechanism of the scavenging the free radicals. Additionally, basically 37 compounds were exclusively identified in the positive. We are using a positive and negative ionization mode, and total we confirmed the 394 compounds, and when we screening them to narrowing down, so 37 we have 48 compounds in final phase by having a standard and the confirmed chemistry, and 37 compounds were exclusively identified in the positive ionized mode and 11 in the negative ionization mode. So primary component identified across all the samples is identified as an arotinine, which is basically the flavonone, which is basically the flavonone and belongs to the citrus family, having a very good anti-inflammatory, antioxidant, and anti-cancer effect, and the precursor ion is the 579.1737. Afterward, HPLC analysis revealed that these agroindustrial wastes contain 11 phenolic compounds like gallic acid, catechin, syringic acid, epicatechin, comaric acid, transferalic acid, snipic acid, prosanidine, A2, quercetin, caffeic acid, and camphor, and they are present in a different concentration. However, gallic acid is the quercetin and gallic acid were identified as the predominant polyphenol in all the samples. Predominant polyphenols in all the samples. My future recommendation is that, yes, we should optimize the extraction method to enhance its yield and activity. We are also need to be isolated and characterize the individual phenolic compounds to understand their chemistry, understand their in vitro and in vivo behavior, and understand their strength to tackling some particular disorders. Their biological activities for therapeutic potential should be carried out by using the in vitro and vivo models, and some innovative products or their utilization in functional food or pharmaceuticals should be optimized by getting the academia industry collaboration, by providing some pilot projects to the students, and their results will be validated, and then they can be incorporated in the functional food and pharmaceuticals product development. So the very important thing, we should investigate the environmental implications of these waste valorization, because these are important, and we should need to be apprehend the technologies which can be reduced which can cause the less impact on the environment as compared to other. So we should understand the eco-innovative techniques. We should optimize their parameters, and we should understand which kind of a material, what kind of agriculture waste having what kind of a material. So we identify the products where they can be utilized. So in that way, we can not only reduce the burden on environment, but also can enhance the circular economy, and that could be beneficial for the Pakistan. Thank you very much. Any question? I'm happy to answer that. And one more thing, afterward, I also carried out the in vitro and vivo studies. I also carried out the digital sensory evaluation of these products. I also developed the agri-industrial based coffee and getting a consumer trial in University of Melbourne, Australia. The results are really very encouraging, and I ensure you that people, the waste should not be setting to the only for the animals. It have a many substances, many potentials. So it should be used, should be valorized. They can be utilized into a many products which can be beneficial not only for the human health but also friendly to the environment, and ultimately provide a good boost to the economy of the Pakistan. Thank you very much.